Sheldrickite is a sodium-calcium carbonate fluoride mineral, named in honor of George M. Sheldrick, former professor of crystallography at the University of Göttingen in Germany. Sheldrick is the creator of Sheldrick's computer program widely used for the analysis of crystal structures. Determination of the structure of this mineral required the software's capability of handling twinned crystals. Occurrence: Sheldrickite is a rare mineral found in Mont-Saint-Hilaire, Canada. Mont-Saint-Hilaire is an alkaline intrusive complex in one of the 10 Montérégion hills. A series of plutons is aligned along the St. Lawrence Valley for almost 150 km eastward from Oka to Megantic. Sheldrickite is closely associated with shortite, not 2Ca2CO3, with the crystals being found in a cavity between shortite crystals. Sheldrickite also occurs as flakes and thin seams between crystals of shortite. Sheldrickite is thought to be formed in a late-stage hydrothermal infilling. The associated species of sheldrickite include pectolite, microcline, arfvedsonite, edrine, polylithionite, calcite, fluorite and minor molybdenite, leucosphenite, thenardite, thermonatrite, sphalerite, galena, schererite and cogarcoite. Physical and optical properties. Sheldrickite has two distinct habits. One occurs as a 1 by 1 by 2 aggregate of blocky twined crystals with 0.1 by 0.1 by 0.1 mm individuals. The second habit occurs as a radiating thin white silky flakes to fibrous masses up to 2 mm wide. Each habit was established as the same species by X-ray diffraction, infrared spectroscopy, and electron microprobe data. This mineral is colorless to white, it has a white streak and a vitreous luster. It has a brittle uneven fracture and has good, 001, parting. It has no fluorescence and has a Mohs hardness of 3, and a density of 2.86 ± 0.04 grams/cm2. Crystallography. Sheldrickite is trigonal pyramidal with the space group being p32. This mineral has an axial ratio of 1 to 2.24025, with cell dimensions of A equals 6.718 A ring, C equals 15.05 A ring, Z equals 3 A ring, V equals 588.23 A ring. The precession photographs show sheldrickite to be hexagonal with a diffraction symmetry of 6/m, with space group choices p6222 and p6422. After the solution of the crystal structure, it was shown that the actual symmetry of sheldrickite is trigonal, space group p32, and the pseudohexagonal symmetry is due to merohedral twinning. Structure. The structure of sheldrickite has 4 large cation sites, but only 2 distinct types of polyhedral. The sodium, Na, polyhedron, with its 8-fold coordination, fits the compressed octahedron that is modified by the removal of one edge. The compressed axis corresponds to the Na-F bonds, where the removed edge results in the 4 longer bonds in the polyhedron. Each of these 3 calcium, Ca, sites has a similar stereochemistry and a similar polyhedron, in the 9-fold coordination. The polyhedron fits within the irregular trigonal prism, with the 3 fluorine, F, atoms defining the equatorial plane and the other 6 ligands in the upper and lower face of the prism. The crystal structure of sheldrickite is layered on, 001. In sheldrickite, there are 2 layers of different composition, 1, NaCO32H2O, and 2, CaF. The pseudo-M planes are positioned through the NaCO32H2O layers, and the pseudo-2-fold axis along is at 0,0,0. The carbonate layer is the mixed layer type and the standing on end, CO3, groups are not in a separate layer but occur with the cations and H2O groups. Sheldrickite structure is a combination of the bastnasite, Say, structure with segregated large cation layers and, CO3, layers, and the sebite, Say, structure with integrated large cation and, CO3, groups in the same layer. Sheldrickite has a segregated large cation layer and an integrated large cation, H2O, CO3, layer.